Hello, welcome back to Math 8. This is a video over Section 3, and we're going to be talking about solving equations with rational numbers. So our objectives, we want to identify the least common denominator of fractions to combine like terms and solve equations. And we want to solve one variable linear equations with rational numbers using properties of equality. So let's talk quickly about what a rational number is. So a rational number is a fraction, okay? And remember, fractions are your friend, okay? And guys, fractions, they're always going to be there for you, okay? Like like certain friends that I know that don't want to hang out on a Friday night, fractions are always going to be there for you, okay? So embrace it. Don't sit there and be upset about it, but, that's what we're going to do. So let's go ahead and let's do solving equations with the decimals. So a rational number is a decimal, and let's do a little bit formal definition of a rational number. So a rational number is where the decimals either repeat or end. Okay, and here's an example. Like if I had the fraction 1/2, okay, that is a rational number because the decimals end, so it's 0.5, okay, and that's the last number in our decimal, okay. If we had, say, 1/3, that number would be 0.33333, and so on, and it would just continue on forever, so 0.3 repeating. So that's what I mean by repeating or ending, okay. So any other number that you can express as a fraction whose decimal does that is a rational number. Okay, anywho. Let's go ahead and let's solve these problems involving decimals, okay? And you're probably going to want a calculator for this just to kind of help out and make sure you're doing these problems right. But what I'm going to do here is solve for d, okay? And so, I've got 17.2 times d minus 24 equals 62. So we got to figure out what d is. So what I'm going to do is I'm going to first add 24 to both sides, okay? And then I'm going to get 17.2 times d is equal to 62 plus 24, which is going to give me 86, okay? And then I'm going to divide everything by 17.2, okay? So if I take 86 and divide it by 17.2, that's going to give me a value of 5, that d is equal to 5, okay? Now we can still check our answer, okay? And we can check it by plugging 5 back in for d and do 17.2 times 5 minus 24. Is that equal to 62? Okay, so 17.2 times 5 is going to give us 86. Okay, minus 24 is equal to 62. So 86 minus 24 does in fact give us 62. So 62 is equal to 62. That's a true statement. Therefore, this is correct. Okay, next problem, okay, same thing, we're dealing with decimals. This one has a lot more decimals, and that's okay, but what I want to do is I want to distribute my 2.5. So 2.5 times negative 5 is going to give us 12.5. So I've got negative 12.5w plus 2.5 times 5.3 is going to give us 13.25. So 13.25, and that's all going to equal 58.25. Now, I'm going to subtract both sides by 13.25, okay, to isolate my w. All right. So 58.25 minus 13.25 is going to give us a value of 45. So 45 over here, negative 12.5w here. Now, I'm going to divide both sides by negative 12.5. Divide by negative 12.5, those are going to divide out. So I got 45 divided by negative 12.5, and that's going to give me 3.6. Okay, so W is equal to, negative 3.6. Okay, and so now what we want to do is check, okay, and to see if we're right. So if we check, all right, we're going to get 2.5 times negative 5 times negative 3.6 plus 5.3 is all of that. Let me make sure I did that right. Okay, is equal to 58.25. So let's multiply our numbers here. I've got 5 times 3.6. Both of those are negative, so we're going to get a positive 18 out of that. So I got 2.5 times 18 plus 5.3. Okay, 18 plus 5.3 is going to give us 23.3. 8.25. So you got 2.5 times 23.3. And is that going to equal 58.25? So let's do 2.5 times 23.3. And that, in fact, does give us 58.25 equals 58.25. This is true. Therefore, this is our answer. And that's how we do that. Okay. All right. So let's do a real-world problem. Okay. Involving decimals. All right. And so on this real-world problem, we've got Jerry's Lawn Service charges an initial fee of $4.50 plus $3 an hour. If she is asked to start before 7 a.m., Jerry charges 1.5 times the regular amount. If she made 28.25 on a job that began at 5 a.m., how many hours did Jerry work? Okay. And so on this problem, what we want to do is realize that, Jerry's Lawn Service, they do an initial fee of $4.50, okay, plus $3 per hour, okay? And let's let X equal the number of hours, okay? And then what we'd want to do then, if she is asked to work before 7 a.m., then Jerry charges 1.5 times the regular amount of work. So what we're going to do is we're going to add 1.5 times 3 times 2, okay? And how I came up with that is I did 1.5 times the regular amount, which is 3, so 1.5 times 3, and Jerry worked for 2 hours, okay? And all of this is going to be equal to 29.25, okay? And we want to figure out how long Jerry worked, okay? So let's do this. Let's multiply out our numbers here. I'm going to do 3 times 2 times 1.5, okay? And that's going to give me 9. So I've got 29.25 is equal to 4.5 plus 3x plus 9. So let's combine the 4.5 and 9. All right, and that's going to give me 13.5. So 29.25 is equal to 13.5 plus 3x. Okay, now what I'm going to do is I'm going to subtract the 13.5, okay, from both sides. So I've got, I'm not writing very small, 29.25 minus 13.5 is going to give me a value of 15.75 is equal to 3x. Let's divide both sides by 3 and by 3. So 15.75 divided by 3 is going to give us 5.25, and this is hours. Okay. Now, that's the amount of hours that were worked. So 5.25, so let's write this down. 5.25 hours after 7 a.m., okay, and then 2 hours before 7 a.m., okay? So that's just one, that's kind of a weird problem. How many hours did Jerry work? Total hours, would be 7.25 hours. But, because there is a discrepancy on, what that entails, then, what that question is asking. Are we asking, how many hours after 7 a.m., before 7 a.m., or total? Okay, so that's what we got. All right, let's go ahead and go down here and let's talk about solving equations with fractions. And so on this, what we want to do is solve this just like we would. However, we want to make sure that we were able to add, subtract, multiply, and divide fractions. So on this problem here, okay, I've got z plus 1/9 equals 5/6. Okay, now the difference between this problem and something, say, like x plus 2 equals 3. Okay, there is no difference. Okay, I'm still, I'm subtracting 2 from both sides to get x equals 1. Here, I would do the exact same thing to solve for z. I'm going to, since I'm adding 7/9, I want to subtract 7/9 from both sides. Okay, now when we're adding and subtracting fractions, remember we want to get a common denominator. So here's what my value for z is. Z is equal to 5/6 minus 7/9. Okay, now between 6 and 9, what's my least common multiple? Okay, and what I do is I look at the numbers of 6 and 9. The multiples of 6 would be 6, 12, 18, 24. The multiples of 9 would be 9, 18, 27. Now what I figured out is that 18 is my least common multiple. So this is going to be my common denominator, okay? Now what I want to do is, how do I turn 6 into 18? How do I turn 9 into 18? Well, if I multiply this fraction by 3 over 3 and this one by 2 over 2, we will get common denominators. Now I have to multiply both the numerator and denominator by the same number because I'm not changing the value of 5/6. Excuse me. I'm just changing the size of the numbers in the ratio, okay? So what I'm going to do is I'm going to get z is equal to, now 3 times 5 is 15, 3 times 6 is 18, minus 7 times 2 is 14, over 9 times 2, which is 18. And so now what I can do, because I have a common denominator, I can just write this all over a common denominator. So 15 minus 14 all over 18 is going to give me 1 over 18. And that's my answer. And that's what we're doing, okay? And so that's all I've got, all right? So there's that, okay? Now over here we're going to do a very similar thing, okay? We're going to use the reciprocal to solve for t. Now what I want to do is this, okay? I'm going to solve this the same way I would any other equation. I'm going to first move over my 1/5. So I'm going to subtract 1/5 from both sides, all right? So I get 3/7 times t is equal to 9/10 minus 1/5. Now, between 5 and 10, okay, my multiples of 5 are going to be 5, 10, 15. Multiples of 10 are just going to be 10, 20, and 30, okay? 10 is my least common denominator, okay? So I'm going to multiply 5 by 2 and 2, top and bottom. So here's what we're going to get. We're going to get 3/7 t is equal to 9 over 10 minus 2 over 10. All right, so now, okay, I'm going to get 3/7 times t is equal to 7/10. Okay, now what I want to do, in order for me to move my 3/7 over, we would want to divide it. However, dividing by a fraction is the same thing as multiplying by the reciprocal. So here we'd want to multiply by the reciprocal, okay? And so I would multiply this by 7/3. Okay, so multiply this by 7/3. So what we get as a value for t is the following. We would get that t is equal to, and we just multiply across. 7 times 7 is 49, okay? And then 10 times 3 is 30. So we'd get 49 over 30, and that's how we would leave our answer, okay? And so we're just going to go ahead and leave them like that. And let's move on to the next page. Okay, in this next problem, this is something we can all relate to because we deal with the snow all the time, is that real-world problem involving fractions. When it started snowing Saturday, 2.5 inches of snow were already on the ground. It snowed at a rate of 1/4 inch, 1/4 of an inch per hour. After the storm, 4 3/8 inches of snow were on the ground. If no snow melted during the storm, for how many hours did it snow? So let's do this, okay? I know that I had 2 1/2 inches of snow already on the ground. If it's going to continue snowing at a rate of 1/4 inches per hour, okay, and let's write that as 1/4 x, that's going to equal a total of 4 3/8 inches, okay, where x is going to equal the number of hours. That's our unknown, okay? And that's how I figure that out. You know, I use what the question's asking me to find to help define what my variable is, okay? Now, what I want to do is get rid of these mixed numbers here, okay? Let's do this. In order to get rid of this mixed number, 2.5, I'm going to do 2 times 2 plus 1, okay, to get a new fraction. So what I do is I take my denominator over here, multiply it by my big number, and then add my numerator. And so that's going to give me 2 times 2 is 4 plus 1 is 5 over 2. You keep your denominator, okay, plus 1/4 x, and that's going to equal 4 3/8. So let's do 8 times 4, and then add 3 to that, and that's going to give me 35/8 inches, okay? Now what I'm going to do is I'm going to solve this equation for x, okay? So I'm going to subtract 5/2 from both sides, okay? And we're going to get 1/4 x is equal to 35/8 minus 5/2. Now, I got to, between 8 and 2, okay, my common denominator would be 8. So I'm going to multiply the top and bottom by 4 to get a common denominator of 8. So I've got 1/4 x is equal to 35/8 minus 28. Now, 35 minus 20, let me do this up over here. So I've got 1/4 x is equal to 35 minus 20 is going to give me 15. So this is 15 over 8. Okay, now in order for me to solve this, remember I want to multiply by the reciprocal to move my 1/4 over to the other side. So I'm going to multiply this by 4 over 1. Flip my fraction. That's my reciprocal. Okay, so 4s are going to divide out. 1s divide out. You're simply just left with x, and then you've got 15 times 4, okay, which is going to give you 60 over 8. Now, 60 divided by 8 gives us 7.5. So this snow fell for 7.5 hours. Man, wouldn't it be nice if it snowed for 7.5 hours? I mean, we could really use, I mean, I know we have a good base and, you know, the majority of the lifts are open, but wouldn't it be nice if we had more? Okay. All right, and the next one, it says Alex needs 2 3/4 of yellow paint to paint his living room and 3/4 of a gallon of yellow paint for his bathroom. He also needed a new paintbrush that cost $6. He paid $62 for the paint and paintbrush. How much did the paint cost per gallon? Okay, so we're going to have x equal the number of gallons. Okay, now here's what we got. All right, we have 2 3/4 gallons, okay, x, plus 3/4 gallons, so 3/4 x, plus $6 is going to give us a total of 62. Okay, so 2 3/4, okay, I'm going to do 4 times 2, which is 8, plus 3, which is 11. So I've got 11/4 x plus 3/4 x plus 6 is equal to 62. So 11/4 plus 3/4, I'm just combining my like terms. I'm just going to add 11/4 and 3/4 together to give me a total of 14/4. Okay, x plus 6 is equal to 62. Now I can simplify this fraction of 14/4 and write each of those is divisible by 2. So I write that as 7/2 x plus 6 is equal to 62. Okay, I'm going to subtract 66 from both sides. So 62 minus 6 is going to give us 56. Okay, and that's going to equal, not 65, 56. And that's going to equal 7/2 x. Now, what I want to do is I want to multiply this by the reciprocal to move it over. So I'm going to multiply it by 2/7, multiply this by 2/7. Okay, everything over here is going to divide out, and we're going to get that x is equal to, I'm going to do 56 over 1 times 2 over 7. So 56 times 2 gives me a value of 112. Okay, so x is equal to 112 over 1 times 7, which is 7. So now we're just going to divide that by 7, and that's going to give us a value of 16. So what we know is that the cost per gallon, okay, to answer our question up here, is that we pay $16 per gallon. Okay, and that's what we're looking for. So, all right, that's all I got for this video. Let's get started on it, and we'll see you soon. Thanks a lot. Bye.